looking at a problem here that involves some coordinates, some bearings, and some motion. Okay, so we're going to be using quite a bit of formulas in this example. So let's zoom in and take a look. So we have here Tim. He leaves his shore on a kayak in a direction of east 41 degrees south, and he's going at a constant speed of 2.8 kilometers per hour for basically an hour and a half. Okay, he then alters his route and travels at a constant speed of 3 kilometers per hour for 30 minutes, so half an hour, in the direction of south 17 degrees west. So the question asks, where was he, or how far was he from where he started? So to begin with, let's draw our diagram. Okay, so I'm going to draw here a shore, one side, and this will be the other side of our stream of water. And to indicate the flow of water, we have water going down. Okay, so what do we know here? So he leaves the shore. Let's say Tim starts over here, and he goes in a direction of east 41 degrees south. So I'm just going to draw my little compass here. So I have north, east, south, and west. So he's starting here, he's going east 41 degrees south. So east is this way. And then from there, he's going 41 degrees south. So roughly, let's say that. So that's south of 41 degrees. I'm just going to move my waves out of the way so they don't interfere with my diagram. Put these over here. Okay, so we know he's going in that direction, and he's going for 2.8, he's going at 2.8 kilometers per hour for 1.5 hours. So if I want to find out how far he went, okay, if you recall, speed is equal to distance over time. Well, distance is just going to be speed or velocity times time. And in this case, it's 2.8 times 1.5. And what is that going to give us? 2.8, half of that is 1.4, so 3.8, that'll be 4.2 kilometers. Okay, so for an hour and a half, he goes 4.2 kilometers. I'm going to put that in bold because that's the actual path he takes. So let's just say this is 4.2 kilometers. Okay, so I'm going to do that. He then alters his route, so I'm going back to the reading here, and travels at a constant speed of 3 kilometers per hour for 30 minutes. So the second leg of his journey is 3.0 kilometers per hour for 0.5 hours. And in this case, his distance is equal to v times t, or 3 times 0.5, which is 1.5 kilometers. Okay, well, where is that going to be? Here's our direction, south 17 degrees west. So from this point over here, he's going to go south 17 degrees west, which is roughly this over here. So this is my 17 degrees. And the path he takes is this one here. Okay, I'll just do that with a bold line. And I know that this is 1.5. So this line here is 1.5. I'll drop the units. This one here is 4.2. And I'll also drop the units. So the question is, how far is he from where he started? So he started over here, and he ended up over here. So what we want to find is this value d. Okay, what is d going to be? I'm going to have to zoom in here and probably get rid of a few things because it's getting a little bit cluttered. But let's zoom in on our diagram. Okay, what do we have? Well, in this triangle, because we do have a triangle here, in this triangle we have two sides and an unknown side. And it almost looks like we could use the cosine law if we had this angle here. Okay, because if we had that angle, if I had this, and I have this side, and I have this side, I can use the cosine law for distance to solve for side D. But we have to figure out what that angle is, and it looks like that we can figure it out using some, you know, relationships between the angles and lines and stuff. So I'm going to flesh this out here. Remember, this is an east-west, and then up and down is north-south. And let me clean this up a little bit. Okay, I'm going to put a 4.2 here. I'm just going to clean this up as well. This is my 1.5. Okay, and I'm dropping the units. Now, if you recall, this pattern here, known as the Z pattern or the Z pattern, opposite angles are equal. Okay, so if this is 41, I'll try with the black one here, then this is also 41. Remember, these are parallel lines, right? Because they're both like east-west directions. So I'm going to put those on there, and I get 41 here in the bottom. Okay, so let me write that in. I'm going to cut that out. So I have 41 degrees here. Okay, well, if I figure this out, then I just add them together and I get my full angle. Well, a good thing is that I know that this is 17 over here. This is 90, so 90 minus 17 gives me what? That'll be 80, 73, so 73 degrees, which means the whole thing is going to be 41 plus 73, which gives me 114 degrees. Great. So I'm going to maybe minimize these a little bit. Let me see if I can do that. Looks like it's a bit too hard. So what I'll do is I'll just write, maybe this finer pencil here, 114, and that's the whole thing. So 114 degrees is the whole angle there. And now I'm in a perfect position to start using my cosine law, because now I have my side D, and I will write it over here. So I have D squared equals 4.2 squared plus 1.5 squared minus 2 times 1.5 times, I'll have to scooch this over a little bit, times 4.2 times cosine of 114 degrees. And at this point, we can take out our calculator, bring it over here, and let's start doing the work. So I have 4.2 squared plus 1.5 squared. That'll be 19.89. So I'll just write those in. Minus a whole bunch of calculation here. So I get 3 times 4.2 times, I'll just put it in first like this, 12.6 cos 114. So I'll do times 114 cosine. Because it is a negative, I'm going to have to make that positive. Let me do it again. So negative 12.6 times 114 cosine is equal to that, plus 19.89 equals 25.01. And if I take the square root of that number, which I'm not going to copy out all of this here, I just want to use the most accurate decimal number I can. Oh, I just deleted it. Let me do that one more time. Minus 12.6 times 4. Okay, if I just take the square root of that, well, it's basically equal to 5. So I'll write that over here, 5.0, and I can get rid of that now. And I'm done. Okay, I have my distance, which is 5 kilometers, because that's what we are working in this case. And yeah, I think that's a wrap. So we've used here, direction. We've used also our formulas for, from physics, distance, and speed and whatnot, and combine them together. And then we're using some, grade 9 angle relationships when you have two parallel lines intersected by, a line cutting through them or something. So quite a few ideas being used together to solve this problem, but ultimately it's the cosine law which gives us our final answer.